Hello everyone, my name is Bipin Abram and in today's video we are going to talk about electric field lines. So let's get started. Alright, so in the previous videos we have talked about electric field, we have talked about force, right? And we also know that if, let's say, I have a point charge, let's say, let me call this point charge plus Q, and let me say that I want to find out electric field at some distance r away from this point, and let me call this point P. Then how I'm going to find it? It's pretty simple. The first thing is that I have to bring a positive test charge into its vicinity. Let me place my positive test charge Q0 at that point. The moment I put it, it is going to experience a force because of the electric field of Q charge. Yes or no? It is going to experience a force in that direction, and which we call it electric field because of Q, right? And you can simply find out electric field is defined as the force experienced by the Q0 charge, that is the test charge, per unit the test charge, or when I solve this I'll simply get K Q upon R square. It's pretty simple. This much we have already studied, we know this, right? Okay, now from this equation I know electric field is given as kq by r square, where r is the distance between the charge q and the place where I'm going to find my electric field. Yes or no, right? So it's pretty clear. Your electric field depends inversely upon the square of the distance between the charge and the position where I'm supposed to find out my electric field. Yes or no? So this means the more far from my point charge, the electric field will be less. Now this is a common thing, right? For example, if my charge is here, the electric field at this point will be much larger as compared to electric field at this point. Let me call it point A, point B. So electric field at A will be much larger than the electric field at point B. Why is that? Because the distance is more for B as compared to distance that is for A. I hope that's understandable, right? Okay, now we also know that, for example, if I have a positive Q charge, right? So this positive Q charge, produces electric field throughout its, surrounding, right? It produces electric field all over its surrounding, right? And we all know electric field is a vector quantity, right? So I can represent this electric field by vector symbol. Yes or no, right? And we have just studied that as we go away from the charge, the magnitude of electric field start getting reduced, right? So for example, if my first electric field, let me use different pen, if my first electric field was this, the next electric field will be of shorter magnitude. Yes or no? Very clearly the next one will be even shorter, right? And the next one will be even shorter, right? So as you go forward in time, or I should say as you go forward in space, the electric field, the intensity of electric field or the magnitude of electric field start getting reduced, right? So you can draw it for this one. As you go away, the magnitude is getting less, right? So this representation is actually your electric field representation. But let's say instead of writing it like this, instead of drawing it like this, why not I make a continuous line? Why not I make a continuous line, that is plus Q? Instead of making, I'll just make continuous lines like this. So these continuous lines that I'm making instead of my vectors, these continuous lines is what I term as my electric field lines. We will define it, don't worry, we will define it, don't worry. Okay, so does that mean that we have lost our information about the magnitude or about the strength of our electric field? The answer is no, we haven't lost that information, because in this picture you guys can see, I'm talking about this picture. So in this picture you guys can see, if I talk about the intensity of electric field here, And if I talk about the intensity of electric field here, then very clearly you guys can see that only two field lines are crossing here, right? But in this area there are more than two field lines, right? So definitely it's pretty accurately telling you that electric field density at the center is more as compared to electric field density at this place, right? So the information is still there, but the interpretation is different. That's the only difference here, right? I hope you guys understand that, right? Okay, great. So how I'm going to define it, right? So basically you guys can see the definitions over here. They are imaginary lines originating from positive point charge, okay, such that when a test charge is placed at any point on the line, great, it experiences force in the direction tangent to it. Now what does that mean? Now let's say we have an electric field like this. Now according to our definition says that they are originating from positive point charge. Okay, let's assume that they are originating from positive point charge such that when a test charge is placed at any point on the line, it experiences force in the direction tangent to it, right? That means let me bring a test charge, right? So let me bring a test charge Q naught. Let's say I put it here, I place it over here. The test charge is here. The moment I place this test charge here, this test charge experience a force in the direction tangent to it. Yes or no? It's pretty clear, right? Okay, let me make another. Okay, let's say the electric field lines are like this, right? Again, you bring a test charge, you bring a test charge and you place it over here. The moment you place it over here, it's going to experience a force in the direction tangent to it, right? I hope that is understandable, right? Okay, let's say it is like this, right? So you bring a test charge over there, it is going to experience a force tangent to it, right? In whichever direction your electric field is, in that direction tangent wise the force will be experienced by this test charge, right? I hope you guys understand it. So basically what is your electric field lines? They are imaginary lines which are which are originating from your positive charge such that the moment you place a test charge on it, it is going to experience this test charge is going to experience a force tangential to it. I hope that is understandable, right? Great. So if that is understandable, let's move to some of the properties of our electric field lines, right? Number one, the first property is that no two electric field lines intersect. Pretty interesting. No two electric field lines can intersect. Now what does that mean? In order to understand this, let me draw two field lines. Let's say this is my one field line and this is my second field line, and let me assume that they do intersect, right? So let's say these are my two electric field lines and they intersected, right? Now what is going to happen? The problem with this diagram is that at the point of intersection, if I place a test charge at the point of intersection, if I place a test charge, then the problem is that this test charge has two tangential direction. One is there, another one is there, right? Force 1, force 2. It has two tangential direction, right? Now this is something which cannot happen. How can a test charge have two tangential directions, right? So the question is where this test charge should experience force. Is it in that direction or is it in this direction, right? So because of this violation, no two electric field lines can intersect, because if they intersect, right, that is the thing, at the point of intersection there will be two directions of force experienced by test charge when placed there, right? Because the moment your test charge is placed at the point of intersection, the test charge is supposed to experience force in two direction, which is not possible, right? So I hope that is understandable. So this scenario is not possible. That's why we say that no two electric field lines can intersect, right? Great. Let's move to next property. Next property says that field lines always originates from positive charge and terminates at negative charge. Okay, now what does that mean? It means that if you have a positive charge and if you have a negative charge, so it says that your electric field lines originate from positive charge and terminates at your negative charge. This is how it is, right? So it is starting, you guys can see it is starting, right? This is the start, and here it ends, right? Or I can say here it ends, right? So it starts from positive, ends at negative. I hope that is understandable, right? Let's go to the next part. The next part is that these are continuous lines from positive charge to negative charge, and they don't have sudden breaks. Yes, great. So that, what does that mean? It means that, let's say if you have a positive charge and if you have a negative charge, so these are continuous lines, right? There are no breaks. Like, you cannot draw it like this. For example, the line starts like this and there is a break here and then like this. So this break is not allowed. They are continuous line from positive to negative and there are no sudden break in between, right? So basically they are going from positive to negative and that's it. No sudden break in between. They cannot be braked, right? So if they are breaking in between, that means we're not talking about the same electric field lines, right? I hope that is understandable, right? Let's go to the next note. The next note is that you guys can see here I have a positive charge. So from a positive charge, electric field lines are always radially outward. What I mean by radially outward, it means it is radiating outward. You guys can see electric field lines are radially outward from a positive Q charge. Electric field lines are radially outward, right? You can write it over here. From a positive charge, electric field lines are radially outward. Now when I say radially means basically if I make a circle here, you guys can see if I make a circle here, so these electric field lines will seem as the radius of this circle, right? So they are radially outward, right? They are coming radially outward. They will not come like this. They will come radially outward. They will feel like these electric field lines will seem like they are the radius of some circle, right? Where point plus Q is at the center, right? I hope you guys understand that, right? Great. So if you have a negative charge, the electric field lines will be radially inward. They will be radially inward. I hope I'm making sense. Radially inwards. Electric field lines will be radially inward. Yes, right? So let me write it here. Electric field lines will be radially inwards in the case of minus Q charge, point charge. Yes. So I hope that is understandable. Okay, what will happen if you have positive and a negative charge? It's pretty clear, right? The electric field lines will start from plus Q and terminate at minus Q, right? So very clearly I can say these are my electric field lines, right? They will start from plus Q and they will terminate at minus Q. So electric field lines will be like this. I hope you guys can follow this. Right, so these electric field lines, they are going, they want to go, right, and these are coming. I hope that is understandable. Yes or no? Right. Okay, one more important thing that we have to understand here. Let's now what will happen if we have a positive Q charge and also a positive Q charge? How we are going to draw the electric field lines of these when you have positive charge and positive charge, right? So it's pretty simple, because we know from positive charge electric field lines are always running out, right? So electric field lines will be like this. They will be going out. Electric field lines are going outward, right? From this also electric field lines are going out. They are going out, they are going out, they are going out, right? So you guys can see that, right? These dotted lines are, these dotted lines I have shown so that you guys can guess the axis, but the electric field lines are going out, right? Now let's say what will happen if you have a plus Q charge and a plus 4Q charge. That means this one has smaller magnitude, this one has a larger magnitude. Now how you can draw that, right? It's pretty simple. The only difference is this will, you can draw the electric field lines like this, right? They are going outward. But for this one, electric field lines are like this. They are going outward but with stronger electric fields, right? So you guys can see the difference is this one has stronger electric field, this one has less strong electric field. That is the only difference here, but this is how you're going to draw. Now one important thing, right, this is the question which a lot of people ask. The question is, okay, let's say I have a positive Q charge, right? Now some people will draw 1, 2, 3 and 4 electric field line, right? Any other person can draw, let's say, more than 4. Let's say they draw more than 4 field lines, 1, 2, 3, 4, 5, 6, 7, 8 field lines, right? Now is this correct or this correct? Both are correct. The main sense that you have to understand it, you can make infinite number of lines, you can make 4, you can make 5, you can make 6, right? The only difference is how you interpret it, right? The here also you can see, if somebody asks you the strength of electric field line here and the strength of electric field line here, the only difference is here the strength is less, here the strength is more, because there are 4 number of field lines. The same question can be asked, the strength of electric field line here and the strength of electric field line here. You guys can see the strength over here is less as compared to the strength over here, right? So it does not matter how many electric field lines you make. The main thing that matter is that you represent that electric field lines are going radially outward and the strength of electric field lines is higher at the near to the charge, and as you go away from the charge the strength of electric field lines started getting reduced, right? So that's all for today. I hope you understood the class. So if you have any doubt you can ask me in the comment section, and I hope all of you are doing good. Stay home, stay safe.